Hi, this is Mrs. Myers, and today we are going to learn section 5.5, indirect proofs. This is a new kind of proof. Actually, these are written as paragraph proofs typically. And the idea of these proofs is to use indirect reasoning in order to prove something is true. So basically, indirect reasoning is when you can eliminate other possibilities and then prove that what you're trying to prove is true, basically because you've eliminated the other choices. You've figured out that it can't be false, therefore it must be true. I know this sounds a little confusing, but let's try a quick example. Look at this triangle, NMO. If I said, prove that this is not equilateral, you might start by saying, well, if it was equilateral, then each of these angles would be 60 degrees. And since each of the angles is not 60 degrees, then this is not equilateral. So you basically proved that it's impossible for it to be equilateral. So you proved the opposite of what you were trying to prove. You proved the opposite was impossible. Okay. So, steps for indirect proof. Really the best way to learn this is to see some actually being written. So we're going to get through the steps here, a little bit of the logic, and then we're just going to write a few. Step 1, assume that the negation of the proof is true. For example, why does it keep doing this? Do not show that to me again. Okay. Above, we were proving that it was not equilateral. You will find that a lot of these proofs, the prove statement is often prove that it is not something. When you're proving that it's not something, that's a good time to use indirect proofs. So we're trying to prove that it's not equilateral. So step 1 says assume that the negation of the proof is true. So we assumed then that it was equilateral, the opposite of what we were trying to prove. That's what we assume first. Okay? Then, step 2, use some of the givens and other geometry truths to show your assumption from step 1 can't possibly be true, either because it contradicts a fact that we already know, or it leads to an absurd statement. We will see what we mean by absurd later. Okay, so like in the above example, when we're proving something's not equilateral, first let's assume it is equilateral. Well, if it is equilateral, then we know that all these angles have to be 60 degrees because we learned that with the equilateral triangle theorem. It says all of the triangle angles in an equilateral triangle are congruent, therefore 60 degrees. So assuming that this is equilateral has contradicted a known geometry fact. Angle N is a given. It's at 54 degrees. So the given information here contradicts a theorem that we learned. Therefore, we've pretty much eliminated, this is step 3 now, we've eliminated the possibility that it is equilateral and therefore have proven that it's not equilateral. So your last step is to write a therefore statement. Therefore, since our assumption was from step 1, the opposite of the proof, since our assumption led to a contradiction, then our proof must be true. Okay, the logic of these indirect proofs is based on the fact that a statement and its negation cannot both be true. In other words, if P is true, then not P must be false, and vice versa. So by proving in this example up above that that this triangle can't possibly be equilateral, we've therefore indirectly proven that it must not be equilateral. Okay, because it can't possibly be equilateral. We've proven that it's impossible for it to be equilateral. Therefore, we've proven that it is not equilateral. Okay, so this is a little practice here of finding the negation of a statement. So if the statement says, something is 4, then the negation of that is that something is not 4. Let's say x is 4. Well, the negation, x is not 4. If something is congruent, the negation of it would be not congruent. If something is greater than 7, then it's not greater than 7, but that includes less than or equal to 7. If you could see this notation here, less than or equal to, there's two possibilities. If it's not greater, it must be less than or equal to 7. Angle ABC is acute. What would the negation be? And my hint here is don't say not acute. Let's be a little more specific here. It's true that the negation is not acute, but what possibilities does that leave us? That leaves us either obtuse or right. Right? An angle can either be acute or obtuse or right. Y is negative. Well, the negation would be y is not negative, which means y is positive, or what? 0. Okay? A is parallel to B. The negation would be A is not parallel to B. We could put a little slash through it, not parallel. So what would that leave us? That leaves us either skew or intersecting. Those are our only choices with two lines. Angle C is not obtuse or acute, then angle C must be right. Okay, so the negation is all the possibilities of the opposite of the statement. So in all of these examples, is it possible for the statement and its negation to both be true? No, they cannot both be true. Therefore, if you prove that some statement here is false, you've basically proven that the statement over here is the truth. Because it can't be both. It's either one or the other. So if the statement from this column, let's say here, if you can prove that angle ABC is acute, if you can prove that this statement is false, then you've basically proven that the angle is either obtuse or right. Okay? So that's what the indirect proofs are doing. To write an indirect proof, you have to be able to identify a contradiction. This is a little bit of an exercise on figuring out what contradicts what, and this involves knowing your geometry knowledge. So if you have three statements, FG is parallel to KL, FG is congruent to KL, and FG is perpendicular to KL. Some of these are different statements, but they're not negations of each other. So sometimes there's contradictions and sometimes there isn't. So in this case, FG is parallel to KL. Could FG be parallel and congruent? Can these statement 1 and 2 both exist at the same time? And the answer is yes, they both can. What about statement 1 and statement 3? Can they be parallel and perpendicular? No. So those contradict. You can't have parallel lines and perpendicular lines. It's impossible. So those statements 1 and 3 actually contradict each other. So here you would say that well, here's the explanation right here. You can read that 1 and 3 contradict each other, but 1 and 2 do not contradict each other. Congruent and perpendicular, those don't contradict each other. So there's different things here. So you guys could try this one. Which two statements contradict each other? I'll give you a second to do it and then come back. Okay, so statements 2 and 3 are the two that contradict each other. You can't have a triangle that's scalene, which means all the sides are different lengths, and equiangular. If it's equiangular, that means it would be equilateral as well. Okay, let's write an indirect proof. So this first example here says, here's our given, and here's our proof. Notice our proof is to prove that this angle C is not a right angle. So the given says that angle A and angle B are complementary. We don't know what they are, but we know they add up to 90 degrees. So step 1 of the indirect proof, and you're going to write this just like a paragraph. Assume that angle C is a right angle. So you're assuming the opposite or the negation of the proof. Okay, the negation of the proof. So first, let's assume this is a right angle. Okay, so I'm going to draw a new diagram with angle C as a right angle. Well, if angle C is a right angle, then by the triangle sum theorem, the measure of angle A plus the measure of angle B plus angle C equals 180. And if we know it's a right angle, then this is going to be 90. So the measure of angle A plus the measure of angle B equals 90 by subtraction. They actually should have put that there. Okay, triangle angle sum theorem says the three angles add up to 180. So if you subtract 90 from both sides of this equation, at the subtraction property of equality, you get the measure of angle B plus the measure of angle A equals 90 degrees. Therefore, A and B are complementary. Okay, sorry, I meant to up here. I didn't read this very carefully. A and B are not complementary was the given. Not that they are complementary, but they are not complementary. That's a big difference. So, therefore, by this subtraction property, we were able to say that measure of angle A plus measure of angle B equals 90. Well, by definition of complementary, that means that A and B are complementary. But by the given, they really should put some more words in here. They don't make it very clear. But by the given, A and B are not complementary, which is a contradiction. We basically have contradicted the given statement. Okay, therefore, and I'm going to need you to write a longer statement than this, but therefore, since our assumption is false, then angle C is not a right angle. Okay. That one was from the book, and it's really not that well written, unfortunately. Let's write one of our own, and we'll write it a little bit better. A little better explanation is actually necessary here. So here we're trying to prove that OE does not bisect angle JOK. So the first thing we want to assume is the opposite of that. Assume that OE does bisect angle JOK. So again, you might want to draw a new diagram with your assumption marked off. Okay, so let's assume that these two angles are congruent because OE is bisecting angle JOK. Look at the givens. The given says OJ is congruent to OK. We can mark that as congruent. But it says that JE, this one, is not congruent to KE. So it's almost like you have to mark them differently. JE is not congruent to KE. Now, let's assume that OE does bisect angle JOK. Well, if that's true, then we could say, think of a regular proof, what would the next thing you would be able to say would be? Then angle JOK, measure of angle JOK. I'm sorry, let's not do measure first, let's do congruence. Then JOK is congruent to KOE by definition. Bisect. And OE is congruent to OE by reflexive. And we are given that JO is congruent to KO. Or OJ, they say OJ to OK. OJ congruent to OK. That's a given. You're never going to write one of the givens as the opposite of what it is. In other words, we assume the opposite of the proof. The proof. You're never going to assume the opposite of the given. The givens are givens, that they are facts. They are what they are. You can't change them. Okay? So we are given that OJ is congruent to OK. So if you look at these triangles here, we know that this is congruent to itself by reflexive. We know that JO is congruent to OK by the given. If we assume this is bisecting, then this angle is congruent to this angle. So what do we know about these two triangles then? Therefore, triangle OJE is congruent to triangle OKE by SAS. And by CPCTC, JE would be congruent to KE. However, this is where the contradiction comes in. This contradicts our given that JE is not congruent to KE. So, our assumption must be false, and OE does not bisect angle JOK. I want you to pay close attention to this last sentence. I'm always going to look for that last sentence to be worded pretty much just like this. So, or therefore, our assumption must be false. And then you're going to state the proof. OE does not bisect angle JOK. So that's the prove statement. Since we've proven that it's impossible for the negation of that proof, right? We assumed the opposite, and then we proved that was impossible. So if the opposite of it is impossible, then this statement itself must be true. Okay. I'd like you to actually copy down this proof here. Copy it down on a piece of paper. Try to do it yourself and for homework, as part of your homework, and then bring it in and we'll see how you did. Follow the steps. First, assume the opposite of the proof. Then use the steps, use the givens and other theorems that you know to show a contradiction. And then you're going to say, therefore, our assumption must be false, blah, 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 and PZ is not the median. Okay, so see if you could prove that one on your own and bring it to class. Okay, thanks.